I apologize, the setup of it was just like the lessons we were doing in class. I didn't actually create new PowerPoints, but we should still be able to walk through it like we do any other lesson. So this is about period and amplitude of a function. So the first thing I want to talk about is a period, all right? And a period is how long it takes for the function to start over again or to repeat itself. So we already know, and we've already talked about, sine and cosine waves repeat themselves every 2 pi. All right, so 2 pi is the period of the function. Tangent functions repeat every pi, so that would be the period of a tangent function. Now, how do you find the period of a function if you're given the function and it's not a perfect sine t or cosine t? We have another variable in here. So if you see this, the function of t is sine bt, and the cosine of t of bt. B is going to impact our period. So the period is 2 pi divided by b. And for a tangent function, it's pi divided by b. So that's the only difference. If you think about what the periods are, you'll know which formula to use. Okay, now amplitude is how high up or how low it goes. Okay, so in this case, amplitude is a number that sits in front of the function, and it's called a. And we say that a function has an amplitude of the absolute value of a for cosine and sine. Now, obviously, tangent functions don't have a minimum and a maximum, so they have no amplitude. So if you have a question that asks for the amplitude of a tangent function, the answer is does not exist. So let's look at example 1. Example 1 we have here, we have sine of 2t and 2.5 of tangent t, and it wants the amplitude and the period. So to find the period, that's the first thing we're going to do for the first function. Maybe? Okay. So, well, amplitude, I guess, is 1 because the number in front of here is 1. The absolute value of 1 is 1. The period is 2 pi over 2, which is pi. Now for tangent, the amplitude does not exist. Okay, yes, there's a 2.5 here, but that doesn't mean anything. There is no amplitude with a tangent function. These can be tricky questions. Make sure that you answer them correctly. All right, so it does not exist. The period is then pi over 1, which is simply pi. Now, practice 1. I want you to try this one on your own. Okay, pause the video and try this problem on your own without use the formulas that we had, and you might want to make sure you write those formulas down if you haven't done that already. Now, reviewing practice 1, okay, the amplitude is going to be the absolute value of -3, which is 3, and the period is 2 pi over 1, which is simply 2 pi. Okay. Skipping this, example 2. Okay, now example 2 asked us to describe the transformations on the graph, and we need to state the amplitude and the period. So, so this one, if we have a negative inside the function, we're going to flip it across the x-axis. I mean, over the y-axis. I'm sorry, the x-axis is over the other one. So. The amplitude is 1, or the absolute value of 1, and the period is still 2 pi. I don't know if I wrote that down. I don't think I did. But you have to make sure you do that for these ones as well. Oh, I did. Okay, so the amplitude is 1, and the period is 2 pi, because we didn't change anything in here. Okay, practice 2. Okay. Try this one on your own. Give me the amplitude and the period and describe what has happened to the graph. So now we'll go over practice 2. To describe what's going on in the graph, okay, the only thing we have here is a horizontal stretch of 2.6, or you could call it compression. It stretches the graph so it compresses it. of 2.6. The amplitude is still 1. And the period is 2 pi over 2.6. I would leave that like that. Anytime you have those weird numbers, just leave them as is. Skip this. I think there's an example 3 on here. Yeah, example 3. Sketch the graph. All right. So when we sketch the graph, we need to look at what the amplitude is and what the period is. So we look at the amplitude, and this one is 2/3. So we're not going to make, the graph is not going to go up past 2/3 or down past negative 2/3. And this right here, this is going to tell us what the period is, which is how we'll know how far to go. The period is 2 pi over 2, so the period is pi. So we're going to go do an entire cycle in pi. So we draw the graph. I'm going to make note of my -1 and 1, so I know where what I normally should do. And then I'll do 2/3 and negative 2/3. I'm not going to put all the in-between pieces. I'm simply going to go to pi and just make sure that my graph is pretty even amounts. So you notice it's the same graph as sine. It just doesn't go past 2/3 or past negative 2/3, and it ends at pi. Okay, so this one on your own. Go ahead and try this without me first. It's pretty close to the question we just did. And now we'll continue with the going over the practice problem. So on this one, you're going to give me an amplitude of 0.8 and a period of 2 pi over pi. So your period is 2. So I'm going to go up. I'm going to draw my 1 and -1 so that I have my bearings of where I'm at. You can also put pi and 2 pi on the graph if you want to see kind of where it is. So 0.8 and -0.8, and I'm going to go start at 0.8 and come up and end at 0.8. So that's my graph. And I think this is the, yeah, that's the end. Okay, we'll see you tomorrow.